Today comes chapter 4.2 notes, or the word problems. And I actually think these are easier than the linear word problems, if that helps ease your mind. All right, so quadratic word problems will always give you the equation, which is why I think it's easier. So they're asking for key points on the graph. So the vocab that we learned in 4.1 is going to be really important, right? The vertex, the axis of symmetry, concave, y-intercept, x-intercept, roots, all of that stuff. All right. So the equations usually use different variables, but we need to replace them with x and y. So reminders, y is the one by itself, so you probably want an equation that says y equals. X is going to be part of the equation, right? So your x will be on the right-hand side. So I've got some keywords to look for. Anything that asks for a starting point, an initial value, or the original amount is probably looking for your y-intercept. Anything that's asking about the maximum, the minimum, or changing direction, turning around, is probably going to be looking at your vertex. All right, anything that's talking about landing, reaching the ground, or asking how long something is in the air is asking for one of the roots. And as a hint, it's usually the one on the right. Because landing, everything usually happens from left to right, so anything that lands is probably on the right-hand side. And then the last one is either x equals or y equals if it gives you a specific number. So if the problem says 2 seconds or 10 minutes or something like that, it's going to be either x equals 10 or y equals 10, whatever that number is. All right, and then sometimes, since it's a word problem, sometimes it splits it up. Anything asking about time or horizontal movement probably only wants the x value. Anything asking for total or vertical, and specifically in vertical, a lot of times it asks about the height of something. It probably only wants the y value. So you're probably going to go to the y-intercept, the vertex, or one of the roots, but then you're only going to give it the x or the y value depending on what it asks for. So let's look at this in action. So it says determine what each equation is looking for and then solve. And solving means Desmos, so you do have to have Desmos pulled up. So the first one says an object is launched at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, s, so I'm going to underline that, at time 2 seconds, because I do want to know what we're measuring in. After launch is this equation, right? And remember that I want this to be y equals, so this st thing, that's just y, and then negative 4.9, instead of t, I want to write it using x squared, plus 19.6, instead of a t, I want to use x, plus 58.8. All right, and then the question says, when does the object land on the ground? So first off, let's look at the variables. X took the place of t, and up here in the problem, it says t is being measured in seconds. So it's my time. Y is going to be f's, right? It replaced the s over here. And it's measuring height. And I see a lot of things measuring in meters. All right, the question down here, the last line usually. When does the object land on the ground? Well, if we look back at our hint words, landing on the ground kind of combines these two, landing or reaching the ground. So I'm looking for an x-intercept. So let's get that typed into Desmos. All right, so I'm going to make this halvesies here. So the equation is y equals negative 4.9 x squared plus 19.6 x plus 58.8. And again, play around with your zoom a little bit so that you can see the equation. All right, reminder that I want the x-intercept. And this is what I mean when I say it's usually the one on the right. The one on the left, negative 2, so it's asking when, so it's asking for a time, so that's the x value. Saying it lands after negative 2 seconds doesn't make any sense. This is actually the starting point. The landing point, it lands at 6 seconds, right? So when does the object land on the ground? Well, it takes 6 seconds to do so. All right, so let's talk about the next one. The Mason Bicycle Company has created an equation that models their profits based on the sale price of their bike. They've used P to represent their profit, so I'm going to underline there real fast, and S to represent the sale price of the bike. So both of these are talking about money, right? When we write our P equals negative 200 S squared minus, plus 92,000 S minus 8,400,000. And remember, I want to rewrite that as Y equals, so P must be the Y. And that's talking about money, profit. And S, so negative 200, instead of S squared, I want X squared, plus 9,200. Make sure I've got enough zeros there. X minus 8, 4 with 1, 2, 3, 4, 5 zeros. All right, so the S gets replaced with X, and that's also money, right? The sale price is also money. All right, so let me type that in real fast. This one's certainly going to take a second to type in. Y equals negative 200x squared plus 92000x minus 84,2,345. All right, now notice since the numbers are gigantic, you're probably going to have to zoom out quite a bit to see it. Ah, there's the tippy top of it. All right, so let's talk about this guy. They want to make the maximum profit. What should the sale price be? So maximum is one of our words. If I flip back, maximum means I'm looking at the vertex. So the vertex is here, right? And then it specifically asks what should the sale price be? Well, the sale price is S, which we used as the X. So let me write in here, vertex, and specifically the sale price, or the S, so I only want the X value. All right, and the X value is this guy. So that is 2.3 times 10 squared. Is a perfectly legit answer, but if you remember your scientific notation, this is $230, right? Move the decimal twice for the squared. Either answer would be marked as correct. All right, so for the next few, I'm going to go through the first couple, or these 3 columns, and I'm going to let you type it into Desmos on your own to check your answers, so that you don't have to just sit here and watch. All right, so let's talk about the first one. So it's important that you read the whole thing. Fireworks are going to be launched from a platform. The height of the firework, h in meters, x seconds, so x must be the time, after the launch can be modeled by this equation. Jim doesn't realize the fireworks have launched until 5 seconds later. How high are the fireworks after 5 seconds? All right, so I'm underlining all the important stuff. So remember, I've got to rewrite this as y equals, and luckily in this case, x is already x, 20x plus 60. All right, so x is going to be x. That one's nice, and we're talking about seconds. It's a time. Remember, x is usually time. And then y is h. It's replacing the h. And that's the height in meters. All right. Now notice this guy. How high are the fireworks after 5 seconds? This guy is a specific amount, right? This guy is this column right here. Gives you a specific number. So it says 5 seconds. So x is seconds. So this is typing in x equals 5 and seeing where it crosses. And that's just a matter of typing it in Desmos. All right. The next guy is exactly the same beginning. The only difference is this bottom bit. So I'm going to copy some things down. X stays X, and it's measuring the time in seconds. Y is the H, and it's the height in meters. Okay, so it says safety reasons. Firemen have installed a net to catch any large pieces left unburnt. The net is 6 feet above the ground. how long until the fireworks reach the net? So this is another one where it gives us a specific number. The net is 6 feet. That's a height. So in this case, it's going to be y equals 6 because we're talking about the height. All right, so type it into Desmos, see where it crosses. Now, I gave you a hint here. I said there are 2 places, but only one makes sense. One of them is going to be positive, and one of them is going to be negative. So only the positive answer. So it's the same as with x-intercepts. It's usually the one on the right. It's the one that's a positive number. All right, so let's talk about the last 2 then. So same idea. It's the same setup, different question, right? So the ball's height, 8 x seconds. So if I rewrite my equation, I need it to be y equals negative 2x squared plus 4x plus 16. So y is replacing the h, which is the height. And then x is replacing x, which is always nice when that happens, and that's being measured in seconds. So it's my time. All right, how long will it take for the ball to reach the highest point? So if I think back to my vocab from this, highest point is a hint word that I'm looking for the vertex. And specifically, it's asking me how long will it take? So that's a time kind of a question. Specifically, I want the value of the vertex. So the first number of the vertex. All right, and that's a Desmos question. All right, the last one, this got cut off on the page, so if you could please fill that in. I will copy in some stuff. Okay, so the setup is the same. If the dog is at ground level, how long until the ball reaches the dog? So ground level is kind of this guy, right? Reaching the ground, being on ground level, something to do with the ground or the dirt, the earth under your feet. So it's a root, it's an x-intercept. It's the one on the right because that's going to be the positive one. So this is looking for a root. And since it asks me how long, that is a time question. So it wants the x value. And anytime we do roots, it's the one on the right.